Hello everyone, my name is Hannah Diewald. I'm the chief editor of MAFO Ophthalmic Labs and Industry. And today I like to welcome you to our panel discussion about the special topic Future Lab. Today our chairman Peter Baumbach, who's also long-lasting chairman of MAFO the conference, will moderate this discussion round, and therefore I like to hand over to him. Peter.
Yeah, thank you very much for your nice introduction, Hannah. And I would also like to extend a warm welcome to all of you here at the MAFO panel discussion and, of course, to our viewers. As Hannah said, today we're going to talk about the future lab, or the lab of the future. And we thought it's a good idea to split the discussion into three main topics. The first topic is called spectacle lenses. How individual is individual enough? And the second part will be on automation, chances and challenges. And the third and last part of our discussion today will be about the future of spectacle lens production, smart technologies, disruptive technologies. And Hannah will moderate the second topic, and I will do the first and the last one. I'm very happy that we find so special guests for today, or more precisely specialists on each of these topics. Our participants today are José Alonso from IoT, François Breton from HPMAT, or I don't know how I call it, Yariv Haddad from Deep Optics, Andy Huthöfer from Satisloh, and last but not least, Jalie from the University of Ulster. Right at the beginning, I would like to ask everyone to briefly introduce themselves to the group and to our viewers. And I would suggest to start in an alphabetical order, if you don't mind. And that means I would ask José Alonso to introduce himself. Please.
Yeah, thank you. Thank you very much, Peter, for the introduction. I think we can be familiar. We can use our first names. Thank you to MAFO also for the invitation to this discussion panel, which is quite exciting, and the topics are really interesting. Well, regarding to my profile, my career is I'm a theoretical physics from the University Complutense of Madrid, but when I finished my master's degree, I started working. My PhD was related to optical metrology, and later on I started to work also in ophthalmic optics. And most of my career has been quite oriented, not that much to the academic part, but I've always kept a very close relationship with industry. Well, nowadays I keep the position as a professor in the University Complutense of Madrid, and along with two other colleagues, Daniel Crespo and Juan Antonio Quiroga, we started IoT in 2005. And well, it's been a very interesting ride. And nowadays I work, I would say, most of my time at IoT as let's say, scientific advisor. but keep teaching. It's stimulating and interesting.
Mm-hmm. Thank you. And François Breton, maybe can you say a few words to?
Yeah, hello, Peter. Yeah, I am a PhD in organic chemistry, so of course I am familiar with materials, and I graduated quite some time ago. Started with working for big companies like GE and Goodyear before entering the optical sector in the year 1999. And started my career with SDC, then moved to NGL, then moved to FISA before I created my own company named ChemOptics. As the world says it, this was devoted for chemicals for the optical industry. And after some time, I decided to extend this scope to other optical materials, and that's why it became HPMAT, like for high performance materials. And I created some joint venture. One of them is in Russia. That's where I was coming from. It's in Kazan, and but 1 week ago I had to come back from Russia in bad circumstances. I don't know if I would be able to come back, but fortunately, I'm here today and I'm free, and I can speak about everything related to materials and chemistry.
Thank you very much. And do I say Yariv or Yariv, Haddad? Is it pronounced Yariv or Yariv?
Thanks, Peter. It's pronounced Yariv.
Yariv.
With Y, Yariv. Nice meeting you, everyone, and thank you, Hannah, for inviting us, and Peter. Yes, I'm also excited to be here, and I'm also grateful to be on this peaceful environment compared to what's going on these days, and I'm grateful for that. My background is in computer sciences. Actually, I'm not originally from the ophthalmic, not even from the optics industry, but then I did come across this industry, this first electro-optics about 20 years ago, when I joined a small startup that developed technology for mobile phone cameras. And when that company was acquired, I moved on with two of my colleagues from that company, and we formed Deep Optics. That's the company that I'm leading today as CEO and one of the founders. Deep Optics is developing dynamic focal glasses. That's glasses that change dynamically the prescription, the refractive effect of the lenses. And they do that using liquid crystal technology that we developed here. And I'd be happy to talk about that and to learn about other exciting things here.
Mm-hmm. Thank you very much. The name 32 degrees north comes from your location? The location?
Yes, that's correct. So the name 32 North is indeed the brand name for the first product that we launched in the summer of last year. And that's the latitude of Tel Aviv. Mm-hmm. We thought it would be nice to refer to it without being too explicit.
Okay, thank you. And the next one is Andy Huthöfer.
Yeah, thank you, Peter. Also very excited to be here. Thanks for the invitation, of course. My name is Andy Huthöfer, and I am with Satisloh. Satisloh is a large equipment and technology provider for the optical industry. My role at Satisloh is Vice President of Product Management and Marketing. My background is in optics. My dad actually founded an optical store back in Germany many years ago, and so I really grew up in the optical environment. I then ended up studying optometry in Germany, or actually at the time it was still called ophthalmic engineering at the University of Applied Sciences in Aalen, and then went on to work in the optical industry. And I've worked for Zeiss for quite a few years, and then later switched to Satisloh, where I've been working for the last 15 years or so. I'm based in the US, in Richmond, Virginia, but also traveling frequently over to Europe, where our headquarters is. Less frequently now than I used to, but hopefully things are going to normalize a bit more here this year, and I'll be able to visit you all again in Europe. In fact, I'm planning to come to Mido this year.
Okay, thank you, Andy. And Mo, would you introduce yourself?
Yes, good afternoon, and thank you, Hannah, and thank you, Peter, for this opportunity to talk again to MAFO. My name is Mo Jalie. I'm a visiting professor in optometry at the University of Ulster. I teach there pure optics, geometrical and physical optics, but I have a special interest in ophthalmic lenses, in spectacle lenses. And I was fortunate enough to be granted 2 patents on aspheric lenses, one on spherical lenses, if I can use that term, and one on astigmatic aspheric lenses, atoroidal surfaces. I have a particular interest in education, and I think each year that MAFO has had a conference, I have given a talk on some educational aspect that I felt would be of interest to industry, because I'm particularly interested in the education of optical technicians. In the United Kingdom, you don't have to have any basic qualifications to make spectacles. And yet, I've always felt that if people know the reasons why they do what they do, they are more interested and become better in their jobs. So that's me. I've been teaching at Ulster for 25 years. And before that, I taught for 30 years at a college in London, training opticians, dispensing opticians, manufacturers, and contact lens fitters.
Yeah, thank you very much, Mo. So finally, I would like to introduce myself. I've been a professor of ophthalmic optics and optometry at the Aalen University. This is where Andy, the one Andy mentioned, for now almost exactly 20 years. On April 1st in 2002, I started my second career there. And before, I worked for the eyeglass lens manufacturer Rodenstock in Germany, in Munich, for more than 10 years, and was responsible for the development and testing of optical designs, for the mathematical principles behind, and also for their programming. And last but not least, for the technical drafting of eyeglass lens patents. And that's my background. And now I would like to start with the discussion about our first topic, spectacle lenses. How individual is individual enough? And let me introduce this with a short story about these individual lenses, because in the 90s when I was working for Rodenstock, we were very busy working on exactly this project to develop what we today call an individual lens. And I can say our dream at that time was to change the whole production line into a very flexible production, and to calculate the lenses in a totally new way, which was not known before, so that we were able to introduce much more parameters from the wearer than before. And it was, for me, it was a very interesting time, because everything was so new at that time, and we did not know if we could succeed. And the head of Rodenstock, Randolph Rodenstock, he was a physicist, as I am, but he never trusted his physicists. He always wanted to he really had some fear that the new product we were developing would not succeed in the market because it would be too complicated. And that was for us a hard time, because for 2 years or so we developed the new product, the first individual progressive lens at that time, without a real permission of the head of the company. But in these days, it was possible. I think today this would not be possible anymore. Okay, so 20 years ago, it was really a challenge, but today, more and more products, and I would say every premium product in premium markets is now very individual. And the question is, or my first question to the group is, what would you say? How individual is individual enough? Are we at the end of this way, of this 20-year-old way, or are there still features that the wearer could benefit from? And as Hannah said, if you want to answer, please raise your hand so that I know who wants to participate. Okay, Mo, and don't forget to switch on the micro. Yeah, Mo, what is your opinion?
Peter, it's a very interesting question, and the answer may depend on the expectation of the wearer. Let me begin by reviewing what has happened in the last 20 or so years with the introduction of the new way of making lenses using freeform technology. As you know well, in the 20th century, lenses were made by generating and then smoothing and polishing the surfaces using a large range of tools. Usually 2 different ranges, one for smoothing, one for polishing, and ideally different sets of tools for each different refractive index that the company worked with. You can imagine the tool inventory was enormous, and for the most frequently used surfaces, needed to step in 1/8 diopter intervals to ensure that the lenses were produced with powers within the tolerances that were stipulated by the international standards. At the same time, refracting equipment was being developed, which enabled the prescription to be ascertained not to the nearest 1/4 of a diopter interval, but to 1/100th of a diopter accuracy. Freeform manufacturing methods have eliminated the need for smoothing and polishing tools and the need to work in quarter diopter steps. If the prescription could be written and called for a 500th or an even 100th diopter power, it can be produced with freeform machinery just as easily as a quarter diopter power. I'm not sure that the question as to whether the human eye can actually see the difference between powers spaced at such small intervals is a significant question. It's well known that there is a diurnal variation in the power of the eye, and the necessary correction, together with depth of focus effects, depending upon pupil size, might influence the prescription by as much as a quarter of a diopter. What is important, in my opinion, is the fact that the wearer believes that they are getting a pair of made-to-measure spectacles, individual to the wearer. And when one adds the frame parameters in which the lenses are mounted, and for which individuality they seem to be prepared to pay, surely this development must be seen as one which is beneficial to both the eye care practitioner and to the manufacturer.
Okay. José, you are also developing lenses, and what do you think? What is, where is the end of the individualization? When does the wearer cannot differentiate anymore between X and Y and Z version lenses?
Yeah, that's a very difficult question to answer, because the visual system, when you're considering a spectacle lens, I'm referring right now to standard spectacle lenses. Probably we're going to talk later about other solutions which may have other problems or advantages. But for standard spectacle lenses, the main problem is that the overall perception, the overall visual perception depends on many parameters that are in conflict one with each other. So to get the right balance between these many parameters is the difficult question, I think. For example, if we consider a typical general purpose progressive lens, I would say we are very close to the limit about what we can make in order to improve the lens quality. I wouldn't say it is not possible to go beyond current designs, but we are very close to whatever the limit is. I'm sure of that. But still, if we keep thinking about progressive lenses, I think that there are still very clear unknowns of relative to how the visual system interacts with the general geometry of the progressive lens, with the distribution of power, because we can make lenses with different distributions of power, spherical power and cylindrical power, and for a given pattern, we can make the lenses to be optimal in the sense that the astigmatism is not going to be reduced anymore. But still, what is the optimal distribution for each individual? This is something which is not completely answered. I think that the models behind that are not completely known. And I myself, I like to use two computer screens, and I can notice huge difference between different designs of office type progressive lenses. So if we convince the ECP and the final user that having a pair of glasses is a good thing, then being able to produce the ideal designs for the user in different applications could be, I think, is a good way to provide better vision experience for the users. I think there is a way there. From the point of view of strict optical design, I think we already know quite well the interaction between the aberrations in the lens and the aberrations in the eye, but not so much about the distribution of this aberration and the visual tasks or visual needs of the user. I think here we have some path for improvement. Mm-hmm. And in case we could, I mean, in general, technologies could be developed in which the distribution of power can be dynamically changed. I think that could be a very, very big breakthrough, because in that case, we wouldn't need more than just a single pair of glasses to adapt to different conditions.
Mm-hmm. Mm-hmm. Yeah, we will talk about different methods in a sec, but I would also, I can really say from my personal experience that some of these lenses, a lens for the computer, for example, or a lens for a progressive edition lens for sports, they are very useful, extremely useful, and for the specific purpose they are much better than the general progressive lens. Although the first progressives were marketed with the goal one spectacle for everything. That's not true. And if we sum up what we really need, we need at least 5 pair of glasses to have the best to have the best view. But okay, and I also saw glass or progressive lenses for left-handed and right-handed persons, and I did not understand the concept behind really. But I would say some individualization is very good, but there is a point where nobody can see the difference. Yeah, I would like to hand over to Yariv. Haddad, you want to comment on that?
Yes, it's interesting because you mentioned that it would probably require a few pairs of glasses to address the different use cases, or to provide us with the best experience in different scenarios. And I think when you talk about personalization, what we are doing at Deep Optics is we're basically looking. We have a new dimension that we can work with, which is the dimension of time. Our glasses change over time. They're not the same glasses at every given moment. At one moment, they can be focused to the far distance, and then the next moment they can be focused to mobile phone distance or a screen at the office. So in that sense, I think the personalization can be, and that's how we also see it going there, of dynamic nature. So a person can, when we design the glasses, we also develop a mobile app for them, so we can control them, and the user can define different presets. They can define different modes of operation, and we have come across various use cases which we didn't even think of, like like pilot instructors that would like some sort of a monovision that changes between left and right, depending on whether they're guiding and they're sitting on the right side, or if they're sitting on the left side and they're actually flying the helicopter. So these kind of adaptations, these kind of personalizations can actually be done by the person itself, and not necessarily a priori. So in that sense, I think it's quite exciting to see this as being these 5 pairs of glasses or 3 pairs of glasses, but not at the same time.
Mm-hmm. Yeah, this is one of the alternative techniques we will see more and more in the future. And can you describe as the let's say the status of the last developments? How good is actually the quality of these lenses? How large is the aperture? Will you shed some light on this?
Yes, gladly. First, just a comment about your initial story. I was inspired by this because I thought this was this is the normal case of innovation. Like you have technical people, you have engineers, you have scientists that are working not necessarily under direct guidance of managers, asking them to do just that, and that usually leads to really exciting stuff. And it was also inspiring because you were able to achieve this and get to a product regardless of the managerial context. So we have been working also for quite a few years on this tech. And we're now launching the first product, which is sunglasses. One of the reasons we're using sunglasses as the first product is because liquid crystal, which is the fundamental technology for tunable lenses, is a polarizing material. So it is sensitive to the different polarizations of light, and the fact that we're using polarized sunglasses makes it, I wouldn't say easier, but because nothing's easy with this kind of complex developments, but it's the simpler solution compared to the non-polarized solution. So in terms of the maturity, in terms of the status, in terms of how far ahead we are, we're definitely, although we're a few years into development, we're definitely at the beginning of where we see this technology going. Today, we're able to reach 2 diopters. The technology of the lenses in our labs, we also do much more than this, like between -5 to +5 diopters of lenses. But when we are looking at applications that are practical, we think that the good quality that we can target today with 20 millimeters of diameter of a lens, for 2 diopters, we see this as good quality at this point. But going forward, we're looking at extending this diameter and also extending the diopter. And sadly, like many things in physics, there's a trade-off. Like if you want to go one way, you have to pay in the other way. So this is the challenge that we're facing, and this is where we're looking to go with extending the size, extending the diameter of the lens, and then also the range of diopters that we can do with good quality.
Okay. Yeah, we're talking about optical designs, and now we're coming to materials. And with new materials, we can find new optical solutions. But are there also innovations in materials and finishes? What do you think, Andy and François? Can you shed some light on this?
Well, in terms of materials, we have, of course, some limitations. There's been a race to go to the highest possible refractive index. I think the highest commercial refractive index in plastic lenses, organic lenses, is 176. But of course, if we go beyond, then we completely lose transparency. So that's why it's really the limit, and the mechanical properties of the materials that with higher indices are going down and down. In terms of mineral lenses, we went up to 1.9, but that was again in terms of thickness. But since the density was much higher, it was not really beneficial to go to that type of material, because the lens were not so much lighter. So that's where we are stuck, and we have to think about lots of aspects when developing new material for lenses. It's not only the weight, the reflector optical performance, but also the mechanical properties that will have to be. You have to be able to design the lens to give the shape that you want, and also it should have some impact resistance. And these all types of compromise make the choice of materials really limited, and that's why we are always offering on the market the same type of materials. There could be some advantages of going to thermoplastics in the sense of the recyclability issue, which is gaining more and more importance, because of course most of the plastic materials that we are using today are thermosets, meaning that they are not supposed to be recyclable. And that's that's an issue. That's obviously an issue. What we can do from them is just probably grind them and use them as fillers for making some frames in some cases. But thermoplastics, yeah, like we all know polycarbonate, nylon. Nylon's used for sun lenses mostly. But they have other, they don't have good optical performance, as we know. Polycarbonate is not an optical material. It's not an ophthalmic material, I would say, because it has good refractive index, but the AB value is so low that I would never consider the polycarbonate. And I don't think the other thermoplastic materials, such as polysulfones, which have a good high refractive index, like could go up to 1.68, but AB value would go below 20. So you must forget it.
Yeah. Okay. And
yeah, go ahead, Peter.
You said you are an optician and you're working in the marketing department. Maybe you can answer our questions from the perspective of the wearer, of the optician, also a little bit.
Well, I mean, I've been. It's been many years that I've worked as an optician, so maybe not so super up to date. But I did want to comment on your question about materials and finishes. And finishes in this case, I would interpret as coatings. And that is something that we at Satisloh are really close to. And we are constantly trying to anticipate what is the next coating that the industry may be looking for, or if the industry is looking for a coating, we are trying to provide the technology to be able to actually produce it. So in that area, there certainly are a lot of things going on, and new features have been developed or are being developed. I want to mention a few. One has been anti-fog coatings that actually has been around for quite a while, anti-fog, but with the pandemic and people wearing masks so much more, anti-fog has become more of a demand from the industry. So, manufacturers have been responding to that, and there's different approaches of how you can do it. We, for example, we have an anti-fog process where you pre-treat lenses in the coating chamber, And then afterwards, on day-to-day use, the user has a particular cloth and activates the anti-fog properties every morning. Just when he cleans his lenses, he also wipes them with the anti-fog cloth. So that is one functionality. Other functionalities are tinting. Tinting traditionally is being done in a dip process, which is somewhat difficult to control and requires a lot of operator experience to match the correct tint and to make sure that the left lens and the right lens look the same, etc. There's also the way of tinting in a box coater. We call that in-chamber tinting. That is something where we see a bit of a trend, and we've been developing coatings for that. Then there's high contrast coatings, contrast that enhance your vision during the night. So, especially for night driving, that can be a very interesting application. There's coating available for that. And then lastly, there's infrared. There's also a demand for this type of coating popping up. Infrared protection, for eye health. And, all that can be done with specific types of anti-reflective coatings as well. And in fact, forgot to mention UV protection also, right? I mean, there are coatings that you can apply to the lens that avoid the reflection of UV rays into the eye. And then there's blue light protection. Also, when you work all day on the computer, of course, you get a lot of high energy blue light into your eyes. Again, there are coatings that take care of that. So there's many applications where coatings can really help to enhance eyewear, provide a consumer benefit, and at the same time also provide a potential source of revenue for the eye care professional.
Mm-hmm. Okay. Regarding Mo, yes.
Peter, I'd like to come back on something that François mentioned earlier. I agree with him that the holy grail for plastics lenses is a 1.8 index. 1.8, François, but with an Abbey number of 40, please. Now, there's a very helpful rule that I teach my students. If you divide the Abbey number by the power of the lens, then you get the distance in millimeters from which the eye can rotate from the optical center before it encounters a tenth of a prism diopter of transverse chromatic aberration. And we consider a tenth 0.1 diopters to be the threshold value for the human eye. So anything smaller than 0.1 is not a problem. Now, if you take polycarbonate, which has an Abbey number of 30, a 1 diopter lens leaves a 30 millimeter zone around the optical center within which the chromatism does not exceed 0.1 diopter. With a 2 diopter lens, it's 15 millimeters radius. So that's a 30 millimeter. You can stroll 15 millimeters. So you've got a circle of 30 millimeters and so on. Of course, with a 5 diopter lens, it's only 12 millimeters because it's 5 millimeters, 6 millimeters, 30 divided by 5. So for low powered lenses, such as very young children might wear, fortunately, polycarbonate does have strength advantages and robustness, providing you've managed to put a good coating on them, of course, or Andy has.
Yeah, absolutely. Okay. When I was thinking of the of this question about the individual lenses, I had one other idea I would like to share with you at the end of this first topic. Sometimes I think less individualization is better than more. And what comes to my mind is the $1 glasses from Martin Aufmuth, because there are around 1 billion people in the world who need glasses but do not have the opportunity to buy them. They don't have the money, they don't have an optician in the near of them, and these glasses are made in a very simple way. They cannot correct cylinders, as far as I know, but they have a few different spherical values, and the people with these glasses can really see much better than without glasses. And so my idea was that sometimes it's better to produce a very simple product to help poor people. What we are talking about the highest level of techniques. That's a totally different story. As Mo started with the what did you say, 1/100th of a diopter precision. For sure, no eye can differentiate between 1 or 2/100ths of a diopter, but it's as I see from these $1 glasses, 1 diopter difference to the eye is much better than nothing in some cases. Okay, so thank you. Yeah, José.
Yeah, that's a very nice appreciation, and I think there is another idea related to it, that even in Europe or in North America or in well-developed countries with good economies, there is a lot of people that cannot afford the premium high-end lenses. So another important I think mission on our side is to get at least the first optimized or individualized lenses with a little bit more quality to, let's say, all the population in our countries, in the well-developed countries, because most of them cannot afford the very high premium lenses and have to go with very standard lenses that finally can be improved.
Yeah. Okay. Thank you. I would like to hand over to Hannah now, and to start with the second topic: automation, chances and challenges.